right, so in this video, we're going to be looking at creating probability distribution curves and shading inside of them. So we're going to focus on the standard normal distribution and then creating, if we want to shade within a particular set of values, how we would go about doing that. So the first thing that we're going to do is we're going to specify some values that we want in our graph. So we're going to use the base R, or the normal distribution standard values, the mean of 0, standard deviation of 1. In R, if you're going to put two commands on the same line, then put a semicolon after each one, and then that'll work fine. Or you can put these on separate lines. We're also going to specify for our example, the lower bound to be a z-score of negative 1.64 and the upper bound to be a score of 0.5. And now we're going to create a sequence of values that we can use to create our normal distribution plot. So we're going to first calculate the sequence from -4 to 4, a length of 100. So it's going to separate this into 100 different values. And then it's going to multiply this by the standard deviation that we specified up here. And then we're going to add the mean value. Now, this is not actually going to do anything because the mean is 0 and the standard deviation is 1. But this is a formula that you can use even when your mean is not 0 and your standard deviation is not 1. So we're going to run those as our x values. And then we're going to plug our x values into our dnorm function, which is going to get us essentially the height of our normal curve at each one of these locations with the given mean and standard deviation. And so we're going to run that. And then we're going to plot our two constructs, x along the x-axis, y along the y-axis, as a line graph. And if I run that, I get my standard normal curve. Now, what I want to do then is I want to create a line and a polygon where I'm going to plot just between, let's say, negative 1.64 and 0.5. I want to shade this region under the normal curve. And so I'm going to specify my eyes are going to be x greater than the lower bound and less than the upper bound. And then I'm going to plot that region on the graph colored in red. So if I run this, that specifies my eyes will run in that range of values I specified. I'm going to and then add my polygon here where I'm going between my lower bound, my x values in that range, and then my upper bound values. And then I'm going to color below that all the way down to 0. And then I'm going to add some things onto my graph here. So my area, I'm going to label the probability values. So I'm using the p norms here between my upper bound and my lower bound. And I'm going to paste that onto the graph. So the probability of being between my lower bound and my upper bound, so that z-score being between there. And then again, if I'm using a mean that's not 0 and 1, I would want to specify this as x, not z. But between these two values and the area that I calculate for this probability specified in this case to 3 significant digits. And then I'm going to add the result to my graph. So that's that paste value that I calculated, 64% basically, and then add my axis labels on the bottom. So this would be an example where it's between two values. Now, you do get something that looks a little wonky because eventually it goes down to 0 here, and this isn't a completely vertical line, but it's close enough that this will do for most circumstances. Now, if I want to do something similar, but where one end is essentially infinity, or negative infinity for that matter, then I'm going to change that around a little bit. But a lot of my steps are going to be basically the same. So here I'm specifying I want to go above 1.64 all the way to the right. If I was doing this to the left, then the lower bound would be like negative some big value, and the upper bound would be some finite value. And then again, I'm going to create my sequence for my x's, and then use the d-norm to create the heights of my curve. And then I'm going to plot my curve. And again, I've taken no y label. I put an x label as my z values, my title. And again, I left the axes off my first curve. I'll add those later. And then again, the same type of operation I had before, as long as x is in between my lower bound and my upper bound, I'm going to get my I values, and then I'm going to plot my lines and my polygon. Now this, because it's above 1.64 and then out into the tail, notice my shading is way out on the right end. And then I'm going to calculate the area under that curve. And then I am going to, again, paste the results onto my graph. So this is about 5% out there above 1.64. And then I'm going to, again, add my axis finally at the end. And again, you can do this similar procedure for calculating probabilities way out here in the left tail. Again, you would just specify your lower bound to be a negative large number and your upper bound to be the finite value where you wanted to stop at.